In this video, we'll understand open economy with exchange rate, and we'll use the saving investment model to do so. Let's take two approaches, the analytical one and the numerical one, to draw parallels between the two. So let's set up the model. In this model, we have our production function, which is output as a function of capital and labor. In case of the numerical framework, keep in mind we have labor and capital as exogenous, and that makes output exogenous. That would mean that in a numerical framework, it turns out to be some number. Let's assume 18,000. If this is billions of dollars, then that would be in $18 trillion. Then you have the consumption function, which is one of the component of the demand side, and it has two components, that part which is not related to disposable income and the part that is related to disposable income after taxes. So this CY has the interpretation of marginal propensity to consume. Let's use numbers for this consumption function. C is equal to, let's say, 300 plus 0.8 y minus t taxes. So 0.8 in this model becomes our MPC. The second component of the demand side is the investment, business investments, and that also has two components. That component which is autonomous, not related to interest rate, and the component that is related to interest rate. And keep in mind, this IR is going to be a negative number, meaning, let's say investment function is 5,000 minus 400R. So the idea here is, as interest rate goes up by 1 unit or 1%, the investments will go down by 400. If it's in billions of dollars, we are saying that every 1% increase in the interest rate is going to reduce the investment by $400 billion. And where is this R coming to come from? The R is going to be equal to the foreign interest rate. And the rationale is that if we assume that the domestic bonds and the foreign bonds carry the same amount of risk and maturity and other aspects of the bond, and there is free mobility of capital across countries, that R would be equal to the foreign real interest rate. There is no reason for us to believe that they are different because of arbitrage. So let's assume that in a numerical framework is 5. Government is exogenous, so government spending is G equals G bar, and so are the taxes. So T is equal to T bar, and in numerical framework, let's assume G is going to be 3,000 and taxes is going to be 2,500. Now keep in mind, this is open economy, so we will have net exports, and this net export function again will have that part which is not related to the exchange rate and the part that is related to the exchange rate. So here E is denoting the exchange rate, and NXE, this coefficient, is representing how sensitive is NX to any changes in the exchange rate. Now keep in mind that NXE is going to be a negative number. So that is, let's say, 30, and the idea here is that every 1 unit increase in the exchange rate E, the NX is going to go down by 30. If it's in billions of dollars, you're talking of $30 billion. And that is logical. As the exchange rate appreciates, the domestic goods will become more expensive for the foreigners, and that is going to hurt the exports of the country, and hence NX will go down for an appreciating currency, as well as the imports will become cheaper. Again, that would mean that an appreciating currency is going to mean that NX is going to be lower because the imports are higher. Now the savings, the national savings, is the national income represented by Y minus the private spending represented by C, consumption spending, and minus the public spending represented by G. In terms of numbers, Y is 18,000 in the numerical example that we are dealing with. Consumption is 300 plus 0.8 Y, notice there is Y, and that y in our example is 18,000, and taxes we have assumed to be exogenous, and that is 2,500. And then there is minus government spending, which is 3,000. Now, when you do the math, the national savings in terms of numbers turns out to be 2,300. In equilibrium, we know that the condition that needs to be satisfied is y has to be equal to c plus I plus g plus nx. And of course, the same is the case in the numerical framework or numerical approach, whereby y has to equal to c plus I plus g plus nx. When we move terms, we will have y minus c minus g minus I equals nx. Now, you can clearly see that y minus c minus g is our savings, and minus investments is equal to nx. And this is an interesting identity, because this is capturing the savings investment gap, which is net capital outflow, and this is capturing the trade balance. So, the idea here is the trade balance will have proportional implication on the net capital outflow. This is the amount of flow of capital that is going out of the country on net basis, right. So, of course, you can have a trade deficit, meaning nx can be a negative number, which would mean that investments are greater than your savings. As a result, we are net borrower as a country, and it could be true the other way as well, whereby it could have a trade surplus. So, savings is greater than investments, and the extra saving is now being lended out in the world, right. So, in terms of numbers, we will still continue with the same notation that we have been using on the analytical side, and just plug in the values. We know that y minus c minus g in our example is savings, so that is 2,300, and the investments, notice, is 5,000 minus 400 r. So, that is 5,000 minus 400 r, and r in our example we have assumed to be 5, and that is equal to nx, and notice nx is 5,000 minus 30 times exchange rate. So, this 2,300 minus investments, which is totaling to 3,000, that negative 700 is our net capital outflow. So, here in this example it is negative, meaning there is a capital inflow, meaning we are borrowing from other country and we are running a trade deficit. That has to be equal to 5,000 minus 30 times E. So, when you solve for E, you get minus 700 minus 5,000 divided by minus 30, that is equal to E. So, E is going to equal to, when you do the math, 190. So, the exchange rate, the equilibrium exchange rate is 190. And you can do a similar analysis by plugging the net export function in the analytical framework, as well as the investment function in the analytical framework, right. So, investment function is IC plus IR times R. So, that is going to be savings minus IC plus IR times R, and that is equal to, keep in mind the next function is NXC. So, that part which is not related to exchange rate, and then that part which is related to exchange rate, it's negatively. So, here too, when you do solve for E, you get S minus IC plus IR times R minus that part of NX which is not related to exchange rate, and then divided by how sensitive is NX to exchange rate. So, that becomes the equilibrium exchange rate in the analytical framework.